Okay, let's talk about the interest rates and how we can calculate the asset returns. So the simple interest rate is denoted by this R per year for n years. And the future value of your investment can be calculated by x times 1 plus r to the power n. And here x is how much you invest. It can be $1, it can be $100, and so on. You can use the same equation to get the present value from the future value in n years, and this time you have future value divided by 1 plus r to the power n. So this 1 plus r to the power n is the discounting factor. You need to discount the future in order to calculate the present value x. And in MATLAB, for example, this can be simply done if you want to calculate the future value, and suppose the interest rate is 0.5%, and if you are investing for, let's say, the next 3 years, your investment will grow to 115.76. And similarly, you can do the reverse operation, and if you have, let's say, this number as the future value, now you can divide by the discount factor. If you are not sure, you can use parentheses, and you can see that the present value equals to 100. So you can also solve equation 1, which gives us the future value in terms of the interest rates. In order to, you can solve this same equation in terms of R. If you know the future value and the present value, then you can calculate what's the interest rate for this given n number of years. Similarly, you can also solve the same equation for n, and you can, for example, find out in how many years your initial investment might double, and you can calculate such quantities using equation 4. Remember, compounding is also important in order to calculate the future value. So if you compare equation 1 and equation 5, you will see the important difference. In equation 1, we assumed there is only one compounding per year, and interest rate is R per year. However, in equation 5, our interest rate is actually compounded m number of times per year. So we need to change the formula. So if we do a simple example, for example, let's say the interest rate is 6% and it is compounding twice a year. If I'm investing for 2 years, then I will have, let's say, 2 times 2. So my investment will grow to 112. However, if the compounding is, let's say, 4 times per year, I'm going to have 4 times 2, because in 2 years I will have 8 times compounding. So my investment now grows to 112.64. So you can notice that as we increase this compounding frequency, if it is a monthly compounding, for example, then you will have 112.71. So the limit is, if the compounding frequency goes to infinity, this will approach to 100 times the continuous compounding, which is the exponential function, and this is for 2 years. And we can see in the limit, this is the continuous compounding gives us the higher amount, which is 112.74. Another important concept is the effective annual rate. You can calculate the effective annual rate by equation 7. And if you look at this equation, on the left-hand side, we have the m times compounding future value. This is what we get as a future value if we have m times compounding. And the right-hand side, we have 1 time compounding per year. So in other words, by solving this equation with respect to this RA, we can obtain what is the equivalent effective annual rate if we were compounding 1 time per year. And for the continuous compounding, you can still apply the idea in equation 7. The left-hand side now you can replace by the exponential function, continuous compounding, and the right-hand side, again, you can solve everything in terms of this RA. So this gives us the effective annual rate for the continuous compounding. And let me finally also discuss the simple asset return over monthly or weekly or daily time periods. So once you fix your time intervals, the asset price change from t minus 1 to t can be calculated by this delta pt, and that gives us the net return over month t. And if you define these time intervals as weeks, then this will be the week return over the week t. And similarly, the gross return is the 1 plus RT, and that is corresponding to PT divided by PT minus 1.